So this will be a 55-minute session, or up to 55 minutes if people have. So everyone should be thinking of questions as the speakers say some things about their projects that they're responsible for. Let me just introduce Barry Smith is a senior research scientist here at CCM, and he'll tell us about the codes, the main code that he's responsible for. Miles Studenmeyer is a research scientist in CCQ. And Vikram Mulligan is a research scientist in CCB and co-leader of the biomolecular design group. And unfortunately, Marsha Berger is home sick right now, but very kindly, Kyle Manderley has stepped in, who is one of Marsha's co-developers on a bunch of PD software that you'll hear about. And Kyle is an associate professor in applied math and applied physics and applied math at Columbia University, just uptown. So, to kick things off, I'd love you all just to say take a few minutes, like try and max it out at 5 minutes about what words of advice you have about managing your projects. Maybe you could say in a sentence what your project does, unless you've already said it, Vikram. So, let's start. Well, Vikram, maybe we should start. We'll go down the line. We'll start with you, Vikram.
Okay. So if anyone wasn't here this morning, I work on Rosetta and Masala, which are biomolecular modeling packages for design, structure prediction, docking, and large-scale conformational and sequence sampling. One sentence about advice, is it?
Well, you have, I think, yeah. If you want to, I mean, or you could save it for later if you want to. Right. If you feel like you've already said a lot this morning. So
I guess my one sentence of advice would be keep in mind that your developers are probably scientists who know the science, not software engineers who know software engineering. And wherever possible, either force them to use good software engineering practices or automate things to make it easy for them.
Hi, I'm Miles Studenmeyer, and I'm one of the prime developers of the iTensor software, along with Matt Fishman, who's a research software scientist at CCQ. Let's see, I did have a slide. I mean, we can show that if it's easy.
Does the AV, you send that to AV, right?
Yeah.
Okay.
No worries if not. I mean.
Oh yeah, cool.
Great. Okay. So that's just a bit about iTensor, just real fast. It has like the one goal with iTensor is it has like layers. So we have more fundamental layers that let you do high dimensional operations, or operations on tensors, which is a kind of high dimensional linear algebra. Something we're working on a lot right now with a new hire, Carl Pierce, or who's been here now for almost a year, is better support for high performance. One of our kind of unique aspects is we have this unique kind of, it's like named index interface, but actually goes beyond named indices. It's really like unique indices, like they're actually like really unique because they represent unique vector spaces. So it lets you write code like that, where the indices just kind of find each other like magnets and just kind of snap together. And then at the top, we have more and more powerful high-level algorithms and abstractions, like tools for optimizing common tensor networks, for contracting high-dimensional networks and graphs, and more recently, tools we're building to do function representations. I think in terms of like, to kick off the ideas, I think one I would chip in for how to do development that we're thinking about a lot is kind of like how to do more with less, in the sense of like, a very easy thing to think is, well, if we just had more people, but then that has its own problems. Plus we're in New York and we only have so many offices here and all that. And it's hard to find people who are really both domain experts and real software professionals, just in general. So I think a lot of our thinking is, how can we use really like cutting edge tools and concepts, especially concepts, to get like leverage. So it's like generic programming, sophisticated modern language features, where we can just have less and less code doing more and more and more. So there's less maintenance, less to think about, but it's actually doing more things even faster all the time. That's kind of our mentality a lot.
Excellent.
Could you bring up my slide, please?
Yeah, go to Barry.
So I've been working on the same software package for 29 years. It's called PETSI. It began originally to solve linear systems, but now it has a lot more capabilities in there. My slide presents a lot of material similar to what Alex's slide presented. The red marks are the particular tools that we use. But I think the most important thing to understand when you get to this scale where different subgroups are independently working on their own parts of the larger package for their own future plans, for their own work, you really need a number of people who are committed to the entire package. That is, you can't have people who say, I'm just going to support my part, because then the other parts kind of fall apart. So the best way to do this is to have people whose actually career depends on the entire package working, because they use that to drive their research, or their research uses the building blocks that are in it. And we succeeded very well with PETSI to do this. Some great people whose careers are basically built on academic work they've done by using the software and adding to the software, and continues to be that way. So they really are committed, and they understand that they do have to deal with configure bugs that people report and simple bugs that people report, and answer basic questions and so forth. And if you don't have that committed group, it's really hard to continue along those lines. In addition, you also have to have the code be in such a way that people are brave about changing things. That is, they're not so scared because, oh, I might break something. And that means really good testing, and including making sure that you have test coverage of all your new code. And there are a variety of tools to do this to help you, so that when someone, for example, makes a merge request, it can automatically say, aha, you've introduced all these lines of code that are never tested. And this process is done completely inside the CI. The user doesn't have to do anything. They can go look at the code and then say, I haven't tested this. I'll put in another test or modify the test to do that. And good reviewers would say, oh, we're not going to accept it until we make sure that this is tested. But because we have all this testing that we've built up over the years, we're brave enough to say, I'm going to change it in a way that might break things. But I'm going to assume that the testing is going to find all the things it breaks. It doesn't actually work. When you make the next release, there'll be users who use things in such obscure and different ways that you never thought of, that you don't test. Then you have to go back and fix those too. But if you don't have that braveness, you might as well, in my mind, just be a commercial software developer. And you shouldn't be in our world. But it does require this extensive amount of testing, and it requires that your community is accepting of things might break. Finally, you can't really see the bottom line, but is what happens when a key person disappears from your group because they're now working for Google, something like that. And how do you bring new people into the group who will actually contribute and develop? I'm not really going to say that much about it, except you should never have a piece of the software where only one person can deal with. There should be multiple people who can deal with it, not as well as the best person, of course, but you need to have that. Otherwise, the person disappears and suddenly, oh, our C++ support is gone. And in fact, our person who was putting in most of the C++ did recently move to NVIDIA, actually. And so the rest of us have to be filling that in and have to be prepared from day one to fill it in, because C++ is not portable, never portable in any way. Every time someone uses a new compiler, some construct complains that you have to go and fix. So you can't just use it and forget it. You have to maintain it. I guess that's about all I'll say for now.
Thanks, Barry. Okay, Kyle.
So I think Marsha had a slide.
Um,
Or did
I
that
don't know
not
if
get,
Marsha. I
Yeah.
think it was
Okay.
you- I
So,
think you said it
so
was
I'm filling in with for Marsha.
Yeah.
Sorry, I will try to evoke her, personality. Perhaps I don't know. Try my best. Marsha worked on Cart 3D. It's a NASA code. She had some things to say about it. I'm not going to be able to speak about that. What I will speak about today is about GeoClaw, a code that we've jointly developed across, as many of these other codes across the planet. And, things like GitHub and other tools have really allowed us to, make this work. And some of the experiences we've had, I think, Alex, actually, when you were talking, like, you have to have a hero to answer questions. Unfortunately, I think we have to do that. And maybe that's something to discuss, like, how do we get away from that? Because that's not sustainable, as Barry just mentioned. You can't have someone like that. So just for those of you who don't know, GeoClaw it's very specific to the geophysical community, geophysics community, in particular, in our, shall we say, discussion, it has to do with coastal flooding and climate change in particular. So I can speak towards a few, hopefully more broader topics, including we've had a lot of very rich companies use our code. Our code is BSD, so it's very open. It's anybody who wants to use it can use it. People are making lots and lots of money off of it, and I'm okay with that. But there is some interesting questions there. How do you bring that in? How do you try to address the idea that you have users who are not willing to give back? How does that work? I have some thoughts as well about that, and also, as well as just how do you manage a community like this? So the community, just to give you an idea, it's not as big as, say, Petsy by far, but it's a burgeoning community. Lots of people are engaging in it. We have to do code review, and actually, one of the things I think might be interesting to talk about is continuous integration, because that's been more and more difficult lately. Because say Travis has tried to monetize some of these things, and we've been kind of left out in the cold. GitHub CI is another option. There's lots of tools out there, and how do you figure out which tools are the good ones? It's not even good ones. Like, which tools are the right ones to go towards? I think that would be lovely to talk about.
I could say a few things about the final comment. We use the GitLab testing system, and I would highly recommend it. I think several people in our group did an evaluation with GitHub, and we had used Jenkins in the past and so forth. And the GitLab one is really nice, easy to use, very stable and robust. You're never chasing down servers that are hanging and stuff like that. That used to happen with Jenkins for us all the time. Displays everything nicely in a website where you can actually even save very big files, huge configure files and output files, everything like that. We use it a lot, and we're still not at the limit of they want us to pay. We're getting close to that, but we do maybe at least 15 tests of the entire thing every day. And because of merge requests and so forth coming in. And we're still not at the limit of you're using too much. Now, it doesn't provide any machines. It provides the infrastructure for running your tests. You have to provide the machines, or they can be in the cloud and so forth. Many people are happy just testing on Linux machines in the cloud. We insist on testing on things like FreeBSD and Solaris and so forth. So those machines we have to maintain ourselves, but it still works in the exact same integrated environment. I think it's an unappreciated benefit of GitLab. Drawback is, of course, you're in a different world from GitHub.
Would the others want to comment on the future of continuous integration? What people starting new projects or looking to set up CI should do?
mean, we've had a good experience with GitHub Actions, I would say, for the most part. Some of the things we've done with that have included checking formatting. So these automatic formatters that you can have for various languages is a very nice tool to keep coherence across different developers and contributors, and especially because we'll take, like a lot of projects, we'll take PRs from people that we just heard of, a month ago, and then we don't know how they're going to make the code look. And then something that recently we did was where sometimes the tests would take quite a while to run, and that could sort of slow human development times and things. So we just have like tags you can put in the commits or in the comments, sorry, where you can run sort of the core test by default. And you can also put a comment and say, also run these domain specific tests since this PR is touching that code. But if it doesn't touch that higher level code, there's no way it's going to break, or it's unlikely to break that test, if things are modular enough.
Right.
Yeah. So,
yeah.
Mhm.
So in the Rosetta community, testing is something that's been a huge push for the last, well, I mean, we had tests before it, but last 10 years, we made our tests good. The one weird thing that the Rosetta community does is all the tests, there's physical hardware that they maintain for testing, and for testing on Linux, Mac, and I think they've got one Windows machine as well. And nowadays, I'd say if you're starting a software project, I'd be much more inclined to just look at Git actions and what's available out there. So some of the reason that this was done was this wasn't available when we started this. However, one thing that's unique to scientific software that you don't have so much if you're developing Microsoft Excel or something like that is scientific software typically will run on a huge cluster to do something extremely computationally expensive to produce a scientifically meaningful result. And so that creates a new type of test that we want to have, in addition to unit testing, integration testing, code coverage testing, coding standards testing, so on and so forth. We need scientific tests, which are unusually expensive tests, where you actually say, here's a scientifically meaningful result that the software gave us in the past. Let's just rerun that, like something that was published in a paper, and make sure that we still get that scientifically meaningful result. If, concrete example, if Rosetta could predict the structure of ubiquitin last week, I need to know that Rosetta can predict the structure of ubiquitin this week. And that's probably not as amenable to GitLab or GitHub automated testing systems because it's a very expensive test. I'm not sure about it. Maybe. The other thing that is a slight complication too is because a lot of our code is stochastic, some of the regression testing we have to do with constant random seeds on the same type of hardware. Even if you maintain the same random seed and you go to a different, slightly different chip, you don't have the guarantee that your random numbers are going to be the same. Now that's specific to regression testing, where you just want to see if the output is identical from one revision to another. Yeah.
Just a quick comment, actually, and I think you brought up a really good point, and I think Alex, you brought this up too, is this idea of regression testing, but for performance. I don't think anybody's figured out how to do that, and it's absolutely critical. Like, so Petsy, like, is Petsy running? Says someone made a commit that is making it go slower. It's really hard to test that.
So we do have tests for that. I mean, there are systems that we use that are some standard tools that will do sort of, statistical regression testing of performance based on, past tests, and it actually keeps a history. I'm blanking out on the name of the tool right now, but this can be like automated on GitHub.
It's definitely possible, right? But like, especially when you're getting into larger, testing. I don't know. I don't.
Well, although also, I mean, I would hope, and I know this isn't always so simple with all the different scientific domains, but again, if things are fairly modular, or if your problems kind of fit onto like a scaling curve, I would hope that you could test pieces on smaller problems up the curve and kind of extrapolate the performance upward. Yeah, Olivia has a question.
Yeah. Are we talking about benchmarking small pieces and micro benchmarking, or benchmarking the speed of a bigger piece? Because that's different.
Yeah, we do
And
some
there are
kind of
tools
medium,
for different things.
we do some kind of medium-sized ones.
Yeah, but I just want to clarify
That's a
the
good
question, because these are different. If I just have micro benchmarking of small functions, I use it.
Oh, yeah, okay.
It's a different problem than the whole thing.
Yes.
He says he is.
Yeah, it doesn't seem, or maybe I'll use the other one. Yes,
Ah,
it's better.
yes.
Yes, I'm saying the question is, whether you want to micro benchmark small pieces or bigger piece in the software, and the tools are different to that. So I just wanted to ask which one you're talking.
Totally
That's a
agree.
really good point. In the Rosetta community, we have both. We have a few small benchmarks for performance of individual pieces of the code. That's probably our test suite that has the poorest code coverage, though. We have very specific pieces that we benchmark, and I don't think we're benchmarking everything we should benchmark there. We also, in our scientific test suite, we have some performance benchmarking. So things like, I'm going to allow this giant sampling job to run for 3 hours. Do I get the same order of number of samples as I did before? But there also, we have very poor code coverage. We don't cover all the protocols, and that's a huge challenge. One thing that came up earlier too is there's the difference too between performance testing, looking for absolute speed of the code for a particular problem size, and then performance testing looking at the scaling of the code with problem size, which is even more difficult.
Sure. Generally, that happens at the research when you're making the paper, and that's it, right? So, but
There's another.
Should we move? I want to give people a chance to write to ask new questions and get some audience questions in there as well. Is that okay, Barry? Should we? Yeah. Any question? Jeff, sorry.
Okay, so Katie earlier today was talking about how people and projects respond to incentives, and here I'm hearing that some of these projects, both of fairly recent and of longstanding existence, face resource constraints in terms of people and developer time and responsiveness time. I was wondering if, especially since the topic here is long-term software management, maintaining a sustainable software package over a long period of time, if you could comment on how these things get funded and whether that's, and we're in a luxurious position here, but we also hear all the time about how there's much more willingness to fund new projects than to sustain old ones. And how do you think that environment is now and could be changed in the future to promote sustainable software for the long term?
One thing we're trying, this maybe isn't exactly funding, but I guess it is in a sense, is that we're trying to use different sort of hiring lines at CCQ to support our software efforts. And I think other centers are doing this too, but I'd be curious to hear how much. We are using the research fellow, i.e. postdoc track, to hire people that sort of specifically commit to making their time here as a postdoc primarily about software. And we're hoping to see a lot of success with that in terms of them going on to do great things after they leave Flatiron. And so far, it seems quite successful in terms of, especially in the thing we were initially worried about, which was, would they really do it? Like, would they come here and then go, just start doing conventional research and really contribute, or be serious about the quality, say, of the software that they do. And so far, I'd say it's been very successful on that. Like, I think when you really incentivize people and hire the right people who you can see have a passion for it, I think then they kind of flourish in this environment.
One of the challenges with scientific software, and this is a problem I do not have a solution to, is if you're working for Microsoft and you make $200,000 a year and someone wakes you up at 3 in the morning and says, hey, you broke something, you need to fix it right away. I'd say you're being adequately compensated for that level of irritation. If you're a postdoc and you make $30,000 a year and your job is to produce papers, I do not think that you should have to put up with being awakened at 3 in the morning and told you have to fix this software. the compensation scales and the reward structures in science, for the most part right now, do not reward good software engineering. And the other problem is, if you're a postdoc and you engineer software really, really well, it doesn't help your scientific career that much. You're probably going to be as successful or even less successful than the postdoc who hacked together something, got a good publication out of it, like a scientific result, and then went on to something else. And yeah, I don't have a good solution to that. The one thing I would say is, one of the luxuries about being at Flatiron is we do have money to throw at problems. And this is one place where we can incentivize good software engineering practices. I guess the other thing I would say also is, there are smart ways to use what resources you have to reduce the burden on those who cannot spend a lot of time engineering software. In the Rosetta community, one thing that helped a lot was, we had a postdoc who decided that he was just going to write some Python code templates. Basically, if you want to add a new Rosetta module, instead of coding it from scratch, you run a little Python script that fills in all the boilerplate for you. And then you go and write your actual algorithm. And that had a huge impact on saving dozens or hundreds of people a lot of time and letting them focus on the science they want to do, instead of making sure that they actually set up the thing that they're going to do properly before they actually went and did it. So maybe that's a piece of the solution, but I don't have a full solution to that.
I came to Flatiron specifically to not answer that question.
No, but I think you're making a serious point, because I think we should be really careful not to tie ourselves to things that are dysfunctions outside that we don't have. I mean, we can be different. We can show a different way. We can solve problems. So these are real dysfunctions, but we don't have to like ingest them into our ecosystem.
Any more comments on that?
Just a quick comment.
Oh yeah,
sorry. So I've been advocating and also involved in a lot of the NSF's software sustainability efforts. We'll call them efforts. And there are resources out there. It's probably arguably not enough, and they realize it. They have some ideas about it, and I think that some of us have probably said to them, like, look, this is a drop in the bucket. It's not enough, and maybe we just need to speak more vociferously, like that word, about this, and try to figure out how can we actually do this software sustainability. And actually, I think that's really where this is going, is software sustainability. How do we sustain software that's really impactful to the scientific community? And I don't know that NSF has the ability to do that, to be honest. But they're interested in the conversation. And the DOE and the DOD and all these federal organizations outside of the Flatiron, unfortunately, they have ideas, but they're not acting on them because they don't have the money to act on them. And that's something that I think is interesting to talk about too. How do we actually promote these ideas? So
I think this is
Kelly has had a hand up to suggest.
So just to talk about funding, this is a landscape which I think is changing very rapidly right now, in part because of all these conversations, and because I think from pressure from many different scientific subfields. And so there are a couple models which I think are really worthy of knowing about, especially if you have conversations with your own program officers, with other funding agencies. One is NASA. NASA made a new call in the past couple of years to support the sustainability of software. So NASA, I think, is really, from a federal funding agency landscape, has it figured out, dedicated program officer, really working with the projects, funded like 10 NumFocus projects, Matplotlib, AstroPy, NumPy. NSF, just to echo what you're saying, they're really, really struggling. I don't have optimism within the next 5 years that they're going to be able to figure it out. But I think us continuing, like collectively continuing to put pressure on them from every direction and serving on those panels and seeing what's getting through and like where the loopholes are and how we can change those calls to have more sustainability funding, I think would be really useful. I don't see another way to do it other than with like group effort. Also to give credit to Simon's Foundation, right? So there's a new funding call. So the federal agencies, I think, are doing a good job in terms of software infrastructure. Where I think Simon's Foundation is playing a leadership role is with respect to career tracks. And so, yes, we have the Flatiron Institute. This is clearly heaven. But how do we get those types of roles in the rest of academic culture? And so I don't remember what the call is, but there is a new call from the Simons Foundation for software developers, basically to like fund their first couple of years as a tenure track position. And so getting them into the academic culture to change it from within. And similarly, if you have conversations with people from the Moore Foundation or, all the other private foundations to point, so it helps a lot. So many of the funding agencies are like, oh, we don't know how to do it. Nobody's figured this out. It's like, okay, well, let me show you here are some calls, like everybody else is doing it. You should do it too. Seems to be very compelling. So being familiar with I just want to really like emphasize the role of networking and that your voices matter and that you can really have an impact in changing how this whole landscape is funded.
Yes. Excellent. Thank you. Brian. Okay, that's good. We're probably going to have 20 more minutes, so we should try and cover as many topics as we can.
Barry joked part of the reason he came here is to not answer that last question. I think that's also a lot of sort of the reason why people get into the idealized idea of open source is sort of like Alex, you mentioned in your last talk, like maybe one day someone from Germany will come along and rewrite a routine of yours and it's 3 times faster and you didn't pay them anything. And so I think that's
not why I was excited, but yeah, okay.
Well, no, but I think this is a sort of commonly stated model is that, if you build enough of a community, you'll start to get it for free. And I think sort of as Barry hinted, sort of the golden goose is if you can convert those one-time contributors into repeated things. But I think the question that I'm fascinated by is like, what do you do if you get a contribution and you have to say no to it, but you don't want to scare that person away forever?
Facing that is something we're thinking about a lot. I mean, we thought of one hopefully expedient that'll work well. I mean, maybe other packages have been doing this a lot, so I'd be curious to hear from them, which is in those cases, sometimes a PR is very simple and clear, and we just, let's pull that in, right, like a bug fix. But we have been getting ones that are more complicated, and we're like not sure we really want to have to maintain that new fancy algorithm that someone's trying to push. And so we've been just thinking about encouraging and showing people how to make external packages, and sort of we advertise them on our website. We sort of keep them in our ecosystem, but on the website we say, these aren't supported by us, but here's the person to, and then try to have like a community of that kind of thing happening. I mean, I think like the Trick software has been doing this a bit. And then, of course, we can always over time try to bring pieces in or sort of take lower level pieces in.
Okay, I'm really glad you said that, because that was actually one of my hopes for Masala. One of my thoughts with the plugin architecture was I want to have the option of someone wants to write really specialized code for their particular use case in the context of Masala. It's probably not going to be something that's of interest to all of the Masala users. And so I wanted them to have the option of, this is a plugin for Masala for this specific case. They'll maintain it. I like the idea of saying, yeah, we'll put a link to it on our website, but it's not our job to maintain that software. And also it leaves open the door also for someone's written a plugin that everyone uses. They might be able to contribute that back to the central repository or something like that. I will mention also that open source isn't so One reason that I'm transitioning a little bit away from Rosetta and trying to focus on something else is that Rosetta is not open source. And one frustration that I have is there is a lot of code that I've contributed to Rosetta that I can't use for my own purposes. Like I can't just take it and stick it in another package of my own. I don't own it. And I think it's not just that if a project is open source, someone might do something for you. It's that if a project isn't open source, people are actively disincentivized from doing stuff for you because they can't use that code for their own purposes if they give it to you. Yeah.
I mean, all right, I'll just chime in because I smiled at Bryce, but when you asked your question, Brian, because Bryce wrote a 4 and 5 dimensional generalization of FineFD, and which I did not bring in as a PR, I'm afraid. However, that's really cool, and that I had to just make a decision about can we maintain this, and all of the interfaces we're not going to be able to, but it was happened to be needed. So yeah, you just have to make decisions, and hope then yes. I don't know if I've linked to your repo, but I do have a list of similar repos, the community, this kind of thing in the documentation, and so you just point to them and you hope they'll stay updated and all of this. Yeah, you can't bring in everything, but it didn't put Bryce off. He's here now, so. Who else? Adam.
So I'm curious about code that is related to these major code bases, but are not actually a part of those. So I'm thinking about code runners, analysis, post-processing in general. If you're having these specialty kinds of either data files or whatever, people are going to be writing packages to do analysis of this. And you don't want the entire scientific community to have to write all their own autocorrelation functions or anything. So how are you thinking about bringing in or trying to associate yourself with good packages that are also helping out your code in some way?
I could say a little bit with regard to, for example, mesh handling. So there's a lot of file formats, and then there's tools for pre-processing, post-processing, all those things. What we've ended up having to do is basically write our own code that can load in this stuff and then provide it out again in the formats that people like. So specific layouts of HDF5, for example, that particular packages use and so forth. And it's kind of tiresome because you have to write all these things and then someone goes and changes their format and you have to, you have to write. Usually, but most people who are writing these things are the ones who are actually using that other tool. And so it's not so bad. They have to write this once and then they can just do their computation with PETSI and their analysis with this other tool. And at the same time, everybody else benefits from it because now they can use that other tool also. But we don't have any particular, aside from helping them with understanding our formats and having many examples that you can copy to convert to other formats, we don't have any other mechanism to help that happen.
Kelly, you're gonna, yeah.
So the AstroPi project, this was has developed what's called an affiliated package system. It was actually developed before I joined the group, but it is amazing, and I would definitely recommend it as a model worth considering. So it also fits into this of PRs, which are too big that you don't want to maintain. So if you get a PR that's like this whole new feature that's like either too specific or too big, you can say, oh, this is really great. This would be a great affiliated package. And so the elements to become an affiliated package means that it works within the existing ecosystem, doesn't reproduce functions, right? So you have to use all the stuff that's already in the ecosystem, and it goes through a relatively light code review, which I also think is excellent because it goes through code review. And the code review process is actually very similar to like a JOS, like code review with templates and stuff. And then they get their logo on the AstroPi affiliated projects list. And so it's a nice little feather in one's cap. for a package to be an AstroPi affiliated package. And everything about it, as far as I can tell, is working really well. And the maintainers of most of the packages are happy to review affiliated packages because it's like, oh, more great code, but I don't have to maintain it. Oh, great, I get to tell people about these functions that they didn't know about. Like they enjoy it. So I definitely recommend the affiliated package model.
And I think they actually just to kind of load on to that, the sidekits in general are really good about, and I don't think AstroPi is a sidekit, right? No, it's just an affiliate num focus package. There's a lot of documentation of like how do you do this as best you can and not, you know, turn people off. So yeah, there's definitely some thoughts about this.
One thing that's important when using someone else's code is to be aware of all the things that can go wrong. So things that we have had go wrong in the Rosetta community are the code disappears, in which case, if your software is dependent on it and the build system is dependent on it, now your software is broken because someone else's software is gone, broken, or otherwise altered. Not everyone else uses the same code standards and repo management standards that you use. So if you're using someone else's repo and they have a habit of rewriting Git history, for example, that would be really, really bad. Or if they don't have a well-defined API and things change all the time or whatever else. One thing that I do sometimes, so some external dependencies I assume are safe, like Boost is very well versioned, doesn't rewrite its history, and has been around long enough that I don't think it's going to disappear tomorrow. So Boost is something that I would rely on. If something is a smaller project, like an open source project, where I don't know much about, it solves the problem I want, but I don't know much about how it's managed or whatnot. If the license permits it, what I sometimes do is I fork the project and I make my software dependent on the fork. And then, and I use Git submodules for the submodules, incidentally, if people don't know, are great. It allows you to say, I've got my Git repo and it's associated with another Git repo, but I'm not storing the other Git repo in my repo. So I'll make my project dependent on a submodule, which is a fork of someone else's open source repository. If you do that, you do have to be very careful and make sure that the license that they release their software under permits that, and that it's compatible with the license you want to release your software under. And if you do that, then you have the option in the future of continuing to merge the updates to their repo into your fork of the repo and keeping it current, or keeping your repo a fixed snapshot in time of their repo. The other thing that is hard is parallelism. So if you've got a header-only math library that solves certain mathematical problems, that's great. You can just incorporate that into your project. But if you've got a library that assumes that it's running in a certain environment and that it has exclusive access to the GPU, or one that's going to do its own thread management or something like that, and you're using that as something that you call from a larger piece of software, which itself assumes it's managing the threads or is doing other things with the GPU as well, that can be a problem. So you have to be very careful about what the library you're using is assuming about parallelism in the environment it's in.
Jeremy, maybe. Yeah.
Case where you have several lead developers on like a software project, and they maybe disagree on the direction or some small choices or even big choices. Is it important to have a system like a voting system, or is it important to have one person that just makes the final decision, or which works better? Yeah.
there's a legend in the Rosetta community from before my time about a particular Rosetta developer meeting where there was a bitter battle over whether amino acid residues should be a graph or not. And it apparently got extremely uncivil. I'd say in the Rosetta community, we don't have an official voting system. We have about 10 people whom we unofficially consider the senior developers, and one person in particular whom we all kind of look to as the unofficial leader of the project, who doesn't have strict veto, but he's so experienced that we all respect him so much that we wouldn't really want to go against something that he strongly says ought to be one way. And that's kind of worked. That's a really impossible to reproduce guideline. You set up your project like this. So that's all I can tell you is this has worked for us. I don't know how to set up a project. One thing that I will say that is a bit of a problem in the Rosetta community is because there's revenue, there's a board that controls that revenue. The board is mainly the original PIs of the Rosetta project who haven't really contributed code since the late 1990s, early 2000s. Most of the developers who are actually contributing code do not have direct say over how the revenue is used. Now that's starting to change. They're starting to make more of an effort to actually have some turnover on the board. But I would say I think it is important to establish some sort of governance structure and establish a governance structure that has a plan for generational turnover if you want this to be a long-term software project. I think it is fair for your developers to be frustrated with you if the people making the decisions no longer have a lot of connection to the project itself. I don't know what the ideal governance structure is, but I think there should be a plan for one.
So if you join NumFocus, they force you to set up a governance structure, and as part of the process of applying, and that's where we introduced a governance structure. In the past, it was decision by consensus and deferring to the senior person on occasion when there's sort of a disagreement. I never had to defer to anybody, of course, though often I was wrong, and that's fine, and we make some other decisions. So we've tried to keep that, even though NumFocus has this requirement. So what we've done is we have a group of the real developers, who there were 15 of them, who if you went to the 16th contributor, their contributions in Git were much smaller than the 15th. So it was a natural place to just cut it and say, okay, all these people are voting members. If something that comes up that someone is unhappy with where the consensus is going, they can call for a vote of these 15. And the hope is that won't happen very often. Hasn't happened yet. I don't know if it'll ever happen, honestly, but that is our kind of tiebreaker, that anybody can call for a vote on anything if they feel that they're kind of in the corner and they're right, but they're losing the battle.
Okay, Dan, sorry.
I imagine that maybe all of your software projects started at one point as very small projects. Maybe you joined after they got a little larger, or maybe you were there at the beginning. And I imagine when they were small projects, you probably didn't care about things like breaking backwards compatibility. It's just you. But at some point, there's a transition. And so my question is, when do you start caring about backwards compatibility? And do you care? And really, like, large scale interface changes, when it's a small project, you probably don't have the foresight to say it's going to be huge in 10 years and I want the interface to be XYZ. So how do you manage that trade-off, kind of going from small to large with backwards compatibility and things like that?
I think one thing I would say is I have a strong opinion about some things I hear in the whole general software community, which is I think this is something that's not easy for NIFs to fix, but I think we have a lot of problems that are solvable and are just causing other problems. And we think some of these problems are like deep, but they're actually just like solvable problems, you know. But what I mean by that is, for example, some of these problems, I think if you really dig down, the root of them is just like we don't always have or use good package managers, you know. So many of these problems related to people's code having changes or, you know, dependency. I mean, many of these are just saying, it's like many different ways to say that a very obvious tool like isn't being used or doesn't exist, but in some cases it does. And what I mean by that is that some ways we've dealt with this is just that, you know, you can, in the tools we're using, you can just pin versions that you have dependencies on, and people can even pin ours. So if they need things to be a certain way, they can just depend on the version that is like that. Of course, we've never tried to break backwards compatibility more than we ever have to. We try not to. Something you can do though is kind of do kind of forwards compatible type thing. I don't know if that's the right word, but we can just sort of transition people to a new interface and say, from now on, use this one as much as you can. The old one will be there, but like, just, and then we try to kind of get a sense of our users of, you know, hopefully, you know, that at some point in the near future, 99% of them will be using the new one. And so we try to do moves like that so we can focus on supporting their use of these nicer interfaces.
So one problem we have with that model is Petsy uses a lot of optional packages. Like I'll just pick an example, package X, which changes over time and changes this API a bit. Many of our users also use package X either directly or they use another package that uses package X. And that other package or their own may be working with a different version of package X. And so just pinning and saying, okay, Petsy at this point is going to work with this particular X version doesn't work, because in a sense, you need to have both versions in the application running at the same time. And we don't do stuff like somehow sticking them in different symbol spaces to allow both of them to run at the same time is problematic. So this problem of things changing in different versions in the wide world is actually difficult. And just saying, okay, we'll pin to this version for the next 2 years doesn't work.
And I would also just say that from my experience, you just basically say, oh, Snoopy, you know, not using the other S word. People are using this, and now all of a sudden we have to deal with that. And that was, I think, kind of what we did. And it's like, you know, I don't know. There's no good way to put a delineating line, but you know, all these issues kind of compound on each other at the same time. So I don't know.
There is a convention that if your number is below 1, you can change the API. Once you hit 1, you have to be more careful about changing. There are regular conventions about this stuff that you should follow.
Does that
So-
include yourself or not? Just
No, this is a convention that goes well beyond scientific.
does the
computing.
one include yourself?
No, not
US
one person, version 1.
Oh,
So
version
you'll
one.
have a package
sorry.
like for 3 years will be below version 1.
I was like, if you have one user,
That's the thing.
all right, yeah, sure.
Everybody nobody wants to
I mean, but I guess in
version
the-
1
This
because
is a
of
good
that.
example. That's a great point, because that's an example of, I think, kind of an example of like a solvable problem where if you have a new area of your code that you're piloting, that can be in a different package, and that package can have a different version number. So you can signal through that this part of the code, this overlay, could break, you know, but then it can be built modularly on top of a core that is much more robustly maintained and documented. And, you know, so these kind of things I think can be good solutions for, you know, 95% of a lot of this.
And those are different repos. You're recommending multiple repos.
Correct.
Okay.
And I continue to use a 0.19 package.
Okay.
Better or worse, but
So one thing on the question of backward compatibility, though, that's unique to scientific software development is, I'd argue that in some sense, it is fundamentally impossible to keep scientific software backward compatible. So one thing that I do is anytime I publish a paper, I say, this is the Git SHA1 of the version of Rosetta that I used for this result. If you really want to reproduce the scientific result, you have to pull that version of the software. That's the only guarantee I will give you. And part of the reason for that is we do things like fix bugs. You know, let's say I found that the way we thought our force field was working, it turned out that it was omitting a particular interaction between 2 atoms. And so I'm going to fix that bug. But if I fix that bug, maybe the scientific result that I got a week ago is now no longer going to work. Maybe it was dependent on that bug being there.
You should retract the paper in that case.
I mean,
yeah, but I think you're exaggerating for an example, right?
Yeah.
But
Well,
yes,
actually, small mistakes in the energy function tend to average out. So we do have small mistakes in our energy function that have been fixed over time. What we sometimes do is we put in a flag saying restore old way of calculating this thing, like basically restore old bug.
Right.
But
fortunately, we call that standard equals legacy, right?
Yeah,
Sorry.
exactly. Yeah. But one thing we do try to publicize is for true scientific reproducibility, first go to the version that was used and then compare that to the latest version of the software.
All right, I think it is 1 o'clock. I don't think it is 1 o'clock, and so we should thank the 4 wonderful panelists and go off and enjoy lunch. Thank you.